When splicing 500 kcmil copper conductors, reliability is paramount. Several methods are available, each with its strengths and weaknesses. The two-way compression, or butt splice, connector is considered the most reliable. These mechanical connectors permanently deform the conductors, creating a cold welded connection. This results in a high-strength, low-resistance connection that is unlikely to fail. The next most reliable method involves using terminal lugs on a bus bar. Terminal lugs are connectors that are crimped onto the conductors and then bolted to a bus bar. Bus bars provide a secure and well-supported mounting for the connections, minimizing stress and vibration. Split bolt connectors offer a moderately reliable option. These mechanical connectors use a bolt to clamp the conductors together. While not as robust as compression or bus bar connections, they are widely used because of their ease of installation. Crimp splices are considered the least reliable of these options. They involve crimping a connector onto the conductors using a crimping tool. These connections can loosen over time due to vibration or movement. In addition to these methods, welding presents another common and highly reliable option. Welding is a permanent connection method that fuses the conductors together. It is extremely reliable, but it requires specialized equipment and trained personnel. Choosing the best splicing method involves considering several factors. Firstly, conductor size and type must be considered. Different splicing methods are suitable for different conductor sizes and materials. Secondly, consider the environmental conditions. The splicing method should be appropriate for the specific environmental conditions such as temperature, moisture, and vibration. Thirdly, accessibility and maintenance are crucial. The splicing method should allow easy access for inspection and maintenance. Finally, take into account the costs and availability of each splicing method. Considering these factors ensures a reliable and long-lasting splice. When using two-way compression connectors, ensure that the correct compression tool and die are used for the conductor size and connector type. Proper compression is essential for achieving a reliable cold welded connection. Inspect the completed connection to ensure that the connector is fully compressed and that there are no signs of damage or deformation. With terminal lugs and bus bars, select lugs that are appropriately sized for the conductor and bus bar. Clean the bus bar surface before attaching the lugs to ensure a good electrical connection. Use the correct torque when tightening the lug bolts to avoid damaging the lug or bus bar. Regularly inspect the connections for any signs of loosening or corrosion. When using split bolt connectors, ensure that the conductors are clean and free of any corrosion. Tighten the bolt securely, but avoid over-tightening, which can damage the conductors. Wrap the connection with electrical tape to protect it from moisture and corrosion. Periodically inspect the connection for any signs of loosening or corrosion. When using crimp splices, use a crimping tool that is specifically designed for the connector size and type. Ensure that the crimp is properly formed and that the connector is securely attached to the conductors. Crimp splices are typically insulated, but it is still a good practice to wrap the connection with electrical tape for added protection. Regularly inspect the crimp for any signs of loosening or corrosion. For welding, use a qualified welder who is experienced in welding electrical conductors. Follow all safety precautions when welding, including wearing appropriate personal protective equipment. Ensure that the weld is properly fused and that there are no signs of porosity or cracks. After welding, clean the connection and apply a protective coating to prevent corrosion. When selecting a splicing method, consider the ampacity requirements of the circuit. The splicing method must be capable of carrying the full load current of the circuit without overheating. Consult the National Electrical Code, or NEC, Table 310.15b16 for the allowable ampacities of insulated conductors. Ensure that the splicing method is rated for the voltage of the circuit. Use connectors and materials that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or UL. Follow the manufacturer's instructions for installing the splicing method. Incorrect installation can lead to unreliable connections and potential safety hazards. Consider the long-term reliability of the splicing method. Some methods, such as compression connectors and welding, are known for their long-term reliability. Others, such as split-bolt connectors and crimp splices, may require more frequent inspection and maintenance. Account for the environmental conditions at the splice location. If the splice is located in a damp or corrosive environment, use a splicing method that is specifically designed for those conditions. For example, use waterproof connectors or apply a corrosion-resistant coating to the splice. Provide adequate support for the conductors and the splice. This will help to prevent stress and vibration on the connection. Use cable ties or other supports to secure the conductors to the conduit or other nearby structures. Allow sufficient space for the splice. The splice should not be overcrowded or congested, as this can make it difficult to inspect and maintain. Ensure that the splice is accessible for inspection and maintenance. The splice should be located in a place where it can be easily reached without having to remove or disassemble other equipment. Consider the cost of the splicing method. Some methods, such as compression connectors and welding, are more expensive than others, such as split-bolt connectors and crimp splices. Balance the cost of the splicing method with its reliability and long-term performance. Be aware of the requirements of the local electrical code. The electrical code may specify certain requirements for splicing conductors, such as the type of connectors that can be used or the way that the splice must be installed. Consult with a qualified electrician or electrical inspector if you have any questions about the electrical code requirements. Document the splicing method and location. This will make it easier to find the splice in the future if it needs to be inspected or repaired. Keep a record of the type of connectors used, the date of the splice, and the name of the person who performed the splice. When splicing conductors in a conduit, ensure that the conduit is properly grounded. This will help to protect against electrical shock. Use a grounding bushing or other grounding device to connect the conduit to the grounding system. When splicing conductors, avoid creating sharp bends or kinks in the conductors. This can damage the conductors and reduce their ampacity. Use a conduit bender to create smooth, gradual bends in the conduit. When pulling conductors through a conduit, use a pulling lubricant to reduce friction. This will make it easier to pull the conductors and prevent them from being damaged. When splicing conductors in a junction box, ensure that the junction box is properly sized for the number of conductors and connectors. The junction box should be large enough to accommodate the conductors and connectors without overcrowding. When splicing conductors, use a wire stripper to remove the insulation from the conductors. Be careful not to nick or damage the conductors. Use a wire brush to clean the conductors before splicing them. This will help to remove any dirt or corrosion and ensure a good electrical connection. When splicing conductors, twist the conductors together tightly before applying the connector. This will help to ensure a good electrical connection. When splicing conductors, use a torque wrench to tighten the connector to the manufacturer's specified torque. This will help to ensure that the connector is properly installed and that the electrical connection is secure. When splicing conductors, inspect the completed splice to ensure that it is properly installed and that there are no loose connections. Use a multimeter to test the continuity of the splice. This will help to ensure that the electrical connection is good. When splicing conductors, label the conductors to identify their function. This will make it easier to troubleshoot the circuit in the future. When splicing conductors, keep the work area clean and organized. This will help to prevent accidents and ensure that the splicing is done properly. When splicing conductors, wear appropriate personal protective equipment such as gloves and safety glasses. This will help to protect you from electrical shock and other hazards. When splicing conductors, disconnect the power to the circuit before starting work. This will help to prevent electrical shock. When splicing conductors, follow all safety precautions. This will help to prevent accidents and ensure that the splicing is done safely. When working with electricity, always be careful and take your time. Electricity can be dangerous, so it is important to be aware of the risks and to take the necessary precautions. Splicing 500 kcmil copper conductors requires careful planning and execution. Selecting the appropriate splicing method, considering environmental factors, and adhering to safety guidelines are crucial for ensuring a reliable and long-lasting electrical connection. Always consult with a qualified electrician if you are unsure about any aspect of the splicing process. Remember to always disconnect power before commencing any electrical work, use appropriate safety gear, and double-check all connections to ensure a safe and reliable electrical system. By carefully following these guidelines, one can achieve a safe and reliable splice that will provide years of trouble-free service.